Hello. Uh, in this lecture, we are going to discuss Cauchy sequences. Yesterday, I had developed some concepts regarding Cauchy sequences, and in R, in particular R, I'm saying, okay, in R, I'm not talking about any other metric space. Right now, I'm talking of, okay, right now I'm talking about Cauchy sequences in R, okay. So, let us begin. Yesterday, I derived it for you that uh, what is a Cauchy sequence? I derived the condition for derived the definition. I've written the definition for the Cauchy sequence, and yes, so here it is. A sequence is said to be Cauchy if for every epsilon greater than 0, there exists n belongs to natural, such that for all m comma n greater than equal to n, xn minus xm mod can be made less than epsilon for all n greater than equal to m greater than, I think this should be greater than equal to m. This should be n greater than m greater than equals to n belongs to natural. So this is how you define. This is how you define your Cauchy sequence. Okay. So once you define this Cauchy sequence, today I'm going to discuss more on this. So in R, I can say a real sequence xn is Cauchy if and only if it is convergent, or in real you can say in a complete metric space like real numbers, I can say that every real sequence xn in R, or you can say any sequence xn in R, is, if it is convergent, then it is Cauchy, and if it is Cauchy, then it is convergent. Okay, and today we are going to develop this idea a little bit more. And yesterday, I think due to some interruption, my lecture got actually. Okay, so let me wait for people to join in. Okay, Sahil has joined. Okay, so let us start. I guess people would join in, and we should start. Okay. So yesterday I was doing one question where actually initially I got stuck, and then actually there was an interruption. So let us build from here. So it says that let xn be let xn be a sequence such that modulus of xn is less than equal to 1 plus n upon 1 plus n plus 2n square 2n square. Let us first write definition for Cauchy sequence. At least those who have joined very new should understand what is a Cauchy sequence, and then we'll start. Just give me a minute so that. Just give me a minute. Okay. So for those who have joined today, let me welcome them on this lecture series on real analysis, in which we are going to cover the entire real analysis via problem solving. Okay, so this will serve you as a good, you can say, material for your exam also, for your upcoming TFR exam also, and for other exam like JAM and JEST, and even for NET exam, it will be beneficial. So yeah, electronics आएगा. Yes, indeed. I'll try my level best. I'm searching for faculties right now, so electronics will also be taught. Right now, I'm teaching mathematics, so let me start with. I'm stuck with this pen. Okay. So now let us first start with the Cauchy sequence. So those who have joined today, we were doing Cauchy sequences. And what are Cauchy sequences? A sequence is said to be Cauchy. Let me write. A sequence is said to be Cauchy if xm minus xn mod can be made less than epsilon for all m greater than n greater than equals to n naught belongs to natural. So what does it imply? See, initially when I was talking about convergence of sequences, I was telling that if I'm saying that my sequence is convergent, implies limit xn is equal to x. Or in other words, this particular limit should exist, and it should exist uniquely. Now, it implies what? It implies xn, the difference between xn, that is the element of the sequence, and the limit can be made as small as possible for some natural number, let us say n naught. Now, instead of saying this, I'm saying that if I am saying that my sequence is convergent? It implies the elements of the sequence, you can say, are actually getting confined in this region, when after some natural number, let us say n naught, after some natural number, the elements of the sequence are getting confined in uh, this particular interval, or I can say that my tail of the sequence is getting accumulated here. My tail of the sequence is getting accumulated here. Now, if my tail of the sequence is getting here, so it implies that my difference between the elements also will start to decrease. So difference between the elements, it implies difference between two elements of the sequence. The difference between two elements of the sequence will also start uh, can be made as small as possible. So this is how you define the Cauchy sequence. And if a sequence is Cauchy, then it is convergent. I'm not deriving that, but if a sequence is Cauchy in R, please remember, again I'm saying a sequence xn which is Cauchy in R, or you can say a sequence xn in R is convergent if and only if it is Cauchy. If and only if it is Cauchy. This is a very powerful statement, but remember, this is only true for entire R, okay, not for any other metric space. So I'll come to all those things, but later on. But that is why I'm time and again focusing on R, actually R, okay. So remember, this is the definition for the Cauchy sequence. Now let us think about this question. The question says, let xn be a sequence. So here it is, I think. Okay, so it says that let xn be a sequence such that modulus of xn is less than equals to 1 plus n divided by 1 plus n plus 2n square. Then xn is Cauchy or not? Answer is true. Xn would be Cauchy. Let us see how. Okay, so in order to say this, what I'll do, I know that I can do some sort of, yesterday I was doing this only, so I can do some sort of manipulation, or I told you that manipulation is not actually was not working. Then what I can do, I can write this as 1 plus n plus 2n square, and then I will write that this particular thing is less than 1 plus n divided by 2n square. So instead of dividing by 1 plus n plus 2n square, I'm not dividing by 2n square. So obviously this side is having more weight, okay. So the desired inequality will be this way. Okay, now I can say that xn modulus is less than 1 upon 2n square plus 1 upon 2n. Indeed, I can write that it is less than 1 upon 2n plus 1 upon 2n. Why? Because clearly you know that n square, for all n greater than 1, I can say that my n square would be greater than, or otherwise if it's equal, then it's equal to. In general, I can write for all n greater than 1, n square would be greater than 1, and 1 upon n square would be less than 1 upon n, clearly. So this inequality would be valid. So in all, I can write my xn mod is less than 1 over n. Okay, so if my xn mod is less than 1 over n, similarly, I can write my xm mod will be less than 1 upon n. Now, let us consider, let me first elaborate it. So it implies my xn would lie between minus 1 by n to plus 1 by n, and similarly my xm would lie between minus 1 by m to plus 1 by m. Is that clear? I hope it is clear. Now you see, what do I need to estimate? So I'm writing what do I need to estimate. What do I need to estimate? So what do I need to estimate? I need to estimate this xm minus xn. You can also write xn minus xm. It is one and the same thing, but keep things in mind. We have to estimate this for all m greater than n, and where n is greater than equal to some natural number n naught. Okay, now let us estimate this. So what would be xm minus xn? So if I want to write, if I use this equation number 1 and if I use this equation number 2, so see, xn lies between 1 upon n and minus 1 upon n. And if I write how it, if xm lies between minus 1 by m to plus 1 by m, Even minus xm also would lie between minus 1 by m plus 1 by m. This is something that I'm leaving to you. Just multiply minus on both sides, and this inequality would again shift in a manner that you will get this. I think this is quite easy to see. You can see it on your own. Add these two things up. So add 1 and 2. So what you will get xn minus of xm is less than 1 upon n plus 1 upon m, and it is greater than minus 1 upon n plus 1 upon n. Or in other words, I can write that xn minus xm modulus is less than 1 upon n plus 1 upon m. Is that clear? See, now since m is greater than n, and since m is greater than n, so I can write that 1 upon m is less than 1 upon n. So this will be less than 1 upon n plus 1 upon n. So I can write that my estimate xm minus xn is less than 2 upon n. And I know that as n tends to infinity, 2 upon n tends to 0. And what does it imply? It implies that 2 upon n minus 0 can be made less than epsilon for all n greater than equal to n naught. And what does it imply? It implies that xm minus xn can be made less than epsilon for all n greater than equal to n naught, and n is greater than m is greater than n. So what does it qualify? Does it not qualify the definition for Cauchy sequence? Indeed it does. So therefore I can say that my xn is a Cauchy sequence. Is that clear? If somebody is there, okay. Am I audible? Is that clear? Am I audible? Is that clear? So how many people are watching this? If there are people watching this, please let me know. I hope it is clear. Okay, so there are not many people watching it, so no issues. So this is it. One thing is that this is very much clear. Now let us move further and do a few more things so that you will be able to understand a little bit more about Cauchy sequences. Okay, so what do you think about this sequence that I'm going to write right now on the board? What do you think about this sequence? So I'm just giving you a question, and I think many people would get it, what I want to convey. This is question number 2 in this particular series, and I'm saying that if xn is a Cauchy sequence of integers, if xn is a Cauchy sequence of integers, what can you say about the sequence? What can you say about the sequence? What can you say about the sequence? Okay. So what I have written that my xn is a Cauchy sequence of integers. That is, it only contains the integers. Now I'm asking, what can you say about the sequence? What can you say about the sequence? What can you say about the sequence? I hope 3 people have joined. If there is someone who is listening to me, please let me know. Are you getting my point, or are you not getting my point? If you're not getting it, kindly let me know. Okay, so let me do it for you. So I'm saying that if xn is a Cauchy sequence of integers, Cauchy means what? Cauchy means, again I'm going to write, a sequence is Cauchy if xm minus xn commod can be made less than epsilon for all m greater than n, where n is greater than equal to some n naught belongs to natural. So if this is the definition, this definition holds true, then I can say that my xn is a Cauchy sequence. Now it says that my xn is a Cauchy sequence of integers alone. Okay, so I'm writing that my sequence xn is such that my sequence xn is such that my sequence xn is such that all the elements or you can say xk belongs to natural for all k belongs to natural. Matlab, for each of these Kapish says convergent. Okay, yes, indeed it is convergent, but the assertion is that the sequence will be eventually constant. Yes, indeed, because see, already it is given Cauchy sequence now, so it has to be convergent. I'm saying if it contains only integers, what can you say about the sequence? Sequence would be eventually constant. And even if there is a single person, don't shy away. Please let me know on your comment section what do you think about the questions. Okay, because only your cooperation would make this session interactive. Okay, so sequence would eventually be a convergent. Sequence would eventually be a constant sequence. This is what I want to convey. This is what I want to convey through this particular question. That is why I have asked this question. So what I am saying is, if xn is a Cauchy sequence of integers means what? Each of these elements in the sequence are only integers. So xn is such that all xk belongs to n, where k belongs to n. So all of these elements of the sequence are only integers. Okay. Now you see, this is true for, so I can write given epsilon greater than 0, where epsilon is any arbitrary positive real number, right? So it is any arbitrary positive real number. So if it is true for any arbitrary positive real number that xm minus xn is less than epsilon for all m greater than n greater than equal to n naught belongs to natural, I would say that my xn is a Cauchy sequence. So now it is true for any arbitrary epsilon, let epsilon be less than 1. Since we know that xn is Cauchy, since we know that xn is a Cauchy sequence, what does it imply? It implies that xm minus xn mod can also be made less than 1 for all n greater than equal to some n belongs to natural. In fact, n is greater than m is greater than n. Is that clear? Because it is a Cauchy sequence, it can be made less than epsilon for all m greater than n greater than equal to capital N. This is some natural number. Now, understand, since xn belongs to set of integers and xn belongs to set of integers, and if their difference is less than 1, because you know that difference between two integers is also an integer, and if I'm saying it is less than 1, it indeed implies that xm minus xn mod should be equal to 0 for all m greater than n. Do you understand this? Because see, difference between two integers has to be an integer. Now if it is less than 1 and even it is positive, then only one integer is left, that is 0. What does it imply? It implies that after some m, that is for all m greater than n, you can write your xm would be equals to xn. What does it imply? It implies that for all m greater than n, your xm is equal to xn, and let us say your xn is some xn naught. Okay, let us say xn is some xn naught. So basically it implies that your sequence is eventually a constant sequence because all of the elements are getting equal. So it implies that your sequence is eventually a constant sequence. Is that clear or is that not clear? Only one guy is there today. Kapish is there. Please let me know, Kapish, if that is clear. Okay, so now let us try to do one more question, and that is, let's say in today's series, this is question number 3, and it is extremely important. Okay, it is extremely important. Why? Because this particular definition, you will find it being used at many points, and just prove this particular concept, and this is an important concept. So Let xn be a sequence. Let xn be a sequence such that modulus of xn plus 1 minus xn is less than equal to c times xn minus of xn minus 1, where c lies between 0 and 1. Where c lies between 0 and 1. Then what can be said about xn? So I'm saying that xn is then convergent. Always remember this. Okay, this particular definition is at times referred to as sequence being contractive. So I will write it here. A sequence is said to be contractive if there exists some c belongs to 0 and 1 such that xn plus 1 minus of xn mod can be made less than equal to c times xn minus of xn minus 1. And remember, every contractive sequence in R is Cauchy. Every contractive sequence in R is Cauchy. And if it is Cauchy, then it implies it is convergent. So every contractive sequence is convergent. Every contractive sequence is convergent. Remember this. So this is the definition for the contractive sequence. And remember, every contractive sequence is a convergent sequence. Now let us see how. So what has been given to you? It has been given to you that, let us say, xn plus 1 minus xn is less than equal to c times xn minus 1. So what I can write? Now just pay attention, okay? Xn plus 1 minus xn mod can be written less than equal to c times xn minus 1. Then I can write xn minus of xn minus 1 mod less than equal to c times xn minus 1 minus xn minus 2, isn't it? Okay. And if you just think about it, I can write xn minus 1 minus xn minus 2 mod less than equal to c times xn minus 2 minus xn minus 3, so on and so forth. So if I want to write it in this fashion, let's say if I'm writing xn plus 1 minus of xn, its mod can be written as c times modulus of xn minus xn minus 1, and xn minus xn minus 1 mod is written less than equal to c times this. So this will be less than equal to c square modulus of xn minus 1 minus of xn minus 2. This will be less than equal to c cube xn minus of 2 minus xn minus 3, and dash 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 dash. There would be c raised to power something that I'm not writing right now. Modulus of last terms that you can have is x2 minus of x1. Okay, now what do you think should be here? So you can clearly see whatever was here, like let's say whatever was getting subtracted here was power here. Whatever was getting subtracted here is power of this point, power of c. Whatever is getting subtracted from n here is power here. So what is getting subtracted? What is 1? 1 you can write n minus of n minus 1. You can write 1 as n minus of n minus 1. So clearly I can write it as n minus 1. Is that clear? I hope it is clear. Please let me know if there is a doubt, because then I'm going to move further. And if you do not have a clarity right now, then you can stop me here itself. Okay, so this is how I can write my things. Now we know already that what we need to prove. We need to prove that this is Cauchy. So what I'll do, we need to estimate what? I'm writing it here. Okay, so we need to estimate. Okay, last line. Okay, see, xn plus 1 minus xn is less than equal to c, xn minus 1. And now think about this particular thing. Think about this bracket that I'm making in red. This is less than equal to, c times modulus of xn minus 1 minus xn minus 2. So what will happen? This c and this c will multiply, so you'll get a c square. So your xn plus 1 minus xn ka mod is less than equal to c times xn minus 1 mod. Then this particular thing is less than equal to xn minus 1 xn minus 2. So this c and this c multiply c square, and you will continue likewise. You can clearly see that the index here, that is n minus 2. So whatever is getting subtracted from n, this particular thing is the exponent here. Similarly, this particular thing 3, here is an exponent here. See this particular thing that is getting subtracted from n, this particular thing is an exponent here. So clearly, what is 1? 1 I can write n minus 1. So clearly this would be an exponent here. I hope now it is clear. Please let me know if it is clear. Okay, so now what we need to do when we are talking about Cauchy sequence, we need to estimate this. We need to estimate xm minus xn mod for all m greater than n greater than equals to n naught belongs to natural. I need to estimate this. Okay, I need to estimate this. Now, if I'm estimating this, now what I'll use something called as your modular inequalities. So if you remember triangle inequality, see, what is the hint? You know that hint is given to us in terms of difference of the consecutive terms, right? This is what is the hint. So what is hint given to us? The hint given to us is in terms of the difference of the consecutive terms. So what I'll do, I'll do one thing. Instead of xm minus xn, I'll write xm minus of xm minus 1 plus xm minus 1 minus xm minus 2 plus xm minus 2 minus xm minus 3 dash 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 xn minus 1. So what should I write? Okay, so I'm just making a diagram here so that you should remember. So for all m greater than n, so this is m, this is n. So what I have written, for all m greater than n. So here you will have this n plus 1, here you will have n plus 2, here you will have dash dash dash, here you will have m minus 1, here you will have m minus 2, so on and so forth. So what will happen? If you're nearing to xn, what will happen? You'll get dash 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 xn plus 2 minus of xn mod plus xn plus 1, xn plus 2 minus xn plus 1 and xn plus 1 minus of x. I hope it is clear. Just give me a minute. Let me write it better. Okay. Sorry. So let me write it here. Okay, so sorry. Okay. Okay. So xm minus 2 minus xm minus 3 plus dash 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 dash. Almost the last terms would be some xn plus 2 minus of xn plus 1, and the last term would be xn plus 1 minus of xn and this whole mod, isn't it? So instead of estimating xm minus xn, I have written this, and you can clearly see xm minus 1 is getting cancelled with xm minus 1, xm minus 2 is getting cancelled with xm minus 2, xn plus 1 is getting cancelled with xn plus 1, and you are left with xm minus xn only. Now what is the use of this? So you see, this particular bracket can be written less than equal to modulus of xm minus of xm minus 1 plus modulus of xm minus 1 minus of xm minus 2 plus modulus of xm minus 2 minus of xm minus of 3 dash 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 modulus of xn plus 2 minus of xn plus 1 plus modulus of xn plus 1 minus of xn. This is your established triangles inequality. If you remember, mod of a1 plus a2 plus a3 dash 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 an is less than equal to mod of a1 plus mod of a2 plus mod of a3 plus so on and so forth. I hope it is clear till now. Now, what is the use of this? I already know that xn plus 1 minus xn is less than equal to, so I can write it less than equal to, so xn plus 1 minus xn is less than equal to xn minus 1 mod of x2 minus x1. I hope it is clear. What can you say about xm minus 1? Just think about this. So xn minus 1. So if I'm writing it here. See, just think about this. Okay, just think about this. Okay, so if I'm writing xn minus of xn minus 1, and here there was a c, it is ultimately less than equal to what? It is ultimately less than equal to c raised to power n minus 1 modulus of x2 minus x1. Or in other words, can I not write that x, if I have to replace this n by m, xm minus of xm minus 1 would be less than equal to c raised to power of n minus 2 modulus of x2 minus x1. So what should I write it here? So I'll write here c raised to power m minus 2 modulus of x2 minus x1. Then again this would be what? This would be equal to c m minus 3 modulus of x2 minus x1 plus dash dash dash. At the end you will have c raised to power n minus 1. What can you say about xn plus 1 minus xn? So xn plus 1 minus xn will come here. So what I can write? If I have to write that xn plus 2 minus of xn plus 1, this will be less than equal to c raised to power n modulus of x2 minus x1. Because if I started this series from I started this from here, xn plus 1 minus xn. So xn plus 1 minus xn mod, just think about this and think about this. So xn plus 1 minus xn mod is less than equal to c raised to power n minus 1 x2 minus x1. And obviously, if I think about this, xn plus 2 minus xn plus 1, this will be less than equal to c times xn plus 1 minus of xn mod. And this is less than equal to c raised to power n minus 1 x2 minus x1. So if it comes here, so I can write that xn plus 2 minus xn plus 1 modulus is less than equal to c raised to power n x2 minus x1. So I can write here c raised to power n x2 minus of x1 mod, and then I can write a plus. I hope it is clear. I know this is slightly tricky, but so what is an estimate? So your estimate of xm minus of xn mod is less than equal to c raised to power m minus 2 plus c raised to power of m minus 3 dash 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 c raised to power of n. Then I can write c raised to power n minus 1 times modulus of x2 minus x1. Obviously in exam you don't have to derive all these things, you have to remember this result, because otherwise in exam if you're going to do all these things, then exam is gone. Okay, so now you think about this. I can write, because addition is commutative, I can write c n minus 1, then I can write c raised to power n, then I can write c raised to power n plus 1 and dash 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 c raised to power of m minus of 3 plus c raised to power of m minus of 2, and then you can write modulus of x2 minus x1. Okay, now you think about this. Just think about this. What is this? This is a geometric series, isn't it? This is a geometric series, right? So this is a geometric series. Okay, because C lies between 0 and 1. C lies between 0 and 1. And clearly you can see this is a geometric series. So I can write it is less than equal to A 1 minus of R raised to power number of terms. How many number of terms are here? M minus 2 minus of n plus 1 and again plus 1. Because see, always remember, if I tell you to count from 0 to 100, you count how 100 minus 1, that is 99, and you add 1 also. So I've subtracted m minus 2, I've subtracted n minus 1 from m minus 2. So I'll get this. So this 2 gets cancelled, you have this m minus n. So I'll write m minus n here. Divided by 1 minus of r, this is c, times x2 minus x1, times x2 minus x1 modulus. Now just think about this. Just think about this. So can I not write that my xm minus of xn will be less than c raised to power of n minus 1 divided by 1 minus of c times modulus of x2 minus x1? Because see, here you are subtracting something, so I can write this will be less than c raised to power n minus 1 modulus of x2 minus x1 divided by 1 minus of c. I hope it is clear. So now you think, if I'm yesterday also I told you limit n tends to infinity, a raised to power n is 0 if a lies between 0 and 1. If a lies between 0 and 1, then this is equals to 0. Now clearly, instead of c raised to power n, you can divide this minus 1, so I can write 1 upon c also. So in general, I know that c raised to power n is here and c lies between 0 and 1. So this particular thing will go to 0. This entire thing would go to 0. So I can write that as n tends to infinity, c raised to power n minus 1 divided by 1 minus c times modulus of x minus x1, or I can actually use epsilon in such a manner that you're not able to get it right now. But understand, this would be equal to 0. Isn't it? This limit would be equal to 0 because as n tends to infinity, because c lies between 0 and 1 and there is an n here, so this would be 0. In other words, I can write c raised to power n minus 1 divided by 1 minus c modulus of x2 minus x1 minus 0 ka difference can be made less than epsilon for all n greater than equal to n naught belongs to natural. This is from what? This is from your basic definition. So if your limit is equals to 0, then the difference between the term and the limit can be made as small as possible. Let us say epsilon. So what I can write xm minus xn mod can be made less than epsilon for all n greater than equal to n naught belongs to natural, and obviously m is greater than n. So what does it qualify? It qualifies the definition for the contractive sequence. It implies xn is contractive. It qualifies the definition for Cauchy sequence. It implies xn is Cauchy, and if xn is Cauchy, it implies xn is convergent. It implies that xn is convergent. So always remember, if the sequence is a Cauchy, if a sequence is a contractive sequence, then it is a Cauchy sequence. Then it is a Cauchy sequence. Or you can say, if a sequence is contractive, then it is convergent. I hope it is clear. Is Kapish getting the point? I think Kapish was only there. I hope you are getting it somehow. I know these are difficult questions, but once you are able to go through all these questions, then you're able to go through any difficult thing in your life. Don't worry. Is that understandable? Okay. So I'll move a little bit more into this concept of contractive sequences. And let us say how many people are getting correct answer now. Okay. Now just think about the two sequences that I am telling you. Kapish, is that clear or is that not clear? If it's not clear, please always keep a pen and paper when you are taking my lectures, so that each of these steps you can do on your own. So you are not able to get confused. Otherwise, you'll be confused terribly. Okay. So I hope you'll follow my advice. Now let me show you a few questions, and then you will be able to understand how important is this. How important is this? Okay. So let us do a few questions, and then you'll be able to get what I want to say. So for example, this is your question number 4 in today's series. Okay. Okay. Kapish, did you get the did you get this particular thing, or you did not get this particular thing? Just asking. Okay. So I'm just giving you a question. Let x1 equal to 1. Let x1 equal to 1 and xn plus 1 is equals to 2 plus xn divided by 1 plus xn for all n belongs to natural. Okay, that's good. So for all n belongs to natural. What do you think about the sequence? Is it convergent or not? What do you think about the sequence xn? Is it convergent or not? What do you think about the sequence? So let me let me help you with the concept. See, just now, always remember in these sessions, whenever I'm going to give you some questions, I'm not going to give you questions out of the blue. Okay, so the question will be dependent upon the concept that I have taught you. The concept that I have taught you. So see, so here it is. Okay, so let me do it. Let me do it for you. See, uh, now you just think about whatever I've taught you. I just recently what I taught you. Recently, I taught you the concept of the contractive sequences. Now you see, I already know that my xn plus 1 would be equals to, if I want to write, I can write 1 plus 1 upon 1 plus xn, isn't it? So I can write my xn plus 1 is equals to 1 plus 1 upon 1 plus xn. And now if I calculate xn plus 2 minus of xn plus 1, because xn plus 1 is given, this mod, if I want to just calculate what it will be equals to, it will be equals to 1 upon 1 plus xn plus 1 minus 1 upon 1 plus xn. Okay, and this I can write it as xn minus of xn plus 1 divided by modulus of 1 plus xn into modulus of 1 plus xn plus 1. Okay, so this is how you write here. This is how can write this, how I can write this particular thing. So let us estimate modulus of xn plus 2 minus of xn plus 1. So I have to estimate modulus of xn plus 2 minus of xn plus 1. Good. So Kapish says this is convergent. Good. This is good. Very good. So let us see. Let us use the concept that I've done, and then I can actually show you. Obviously, I can show you by using limit also, but I want to show you the applicability of the concept of contractive sequence here. So I have estimated xn plus 2 minus of xn plus 1 mod. It is equals to this. And understand, if x1 is equal to 1, what do you think about x2? So your x2 would be 3 by 2, isn't it? How would your x3 would be? Clearly x3 would be also greater than 1. So my claim would be that my xn is greater than 1. My claim would be that my xn is greater than 1. If xn is greater than 1, clearly xn plus 1 is what? Xn plus 1 is 1 plus something only. So I can write that xn plus 1 is also greater than 1. Xn plus 1 is also greater than 1. So by principles of mathematical induction, I can write that my xn in general is greater than 1. So by principle of mathematical induction, I can write my xn is greater than 1. What does it imply? It implies 1 plus xn would be greater than 2. Also it implies 1 plus xn plus 1 would be greater than 2. So if I just write it in this like divide it, so what I can say that my xn plus 2 minus of xn plus 1 would be less than 1 over 4 modulus of xn minus of xn plus 1, or you can write this again as xn plus 2 minus xn plus 1 mod is less than 1 over 4 modulus of xn plus 1 minus of xn. So clearly you can see that this qualifies the definition for the contractive sequence. This is the definition for the contractive sequence. Remember, if it is less than C and if C lies between 0 and 1, then this is a contractive sequence. So it implies that the sequence Xn is a contractive sequence. And if sequence Xn is contractive, it implies that Xn is a convergent sequence, isn't it? Xn is a convergent sequence. I hope people have got this particular concept. And obviously you can find the limit as well by claiming that since sequence is convergent, so the limit should exist. And if limit exists, then let us say that limit is L, then it is quite easy to see that L would be equals to 1 plus 1 upon 1 plus L. And then I think it's quite easy to see that this would be L minus 1, L square minus 1 would be equals to this. And you can say that L would be equals to plus minus root 2. Obviously, L cannot be negative. L has to be positive only by the condition for the sequences, because Xn has to be greater than 1. So I hope it is clear. So if anybody is having any problem, please let me know. And if you're getting this particular concept, should I go ahead and do one more question for you? Okay, so try to do this question as a homework I'm giving, and we'll start our lecture from here only tomorrow. Try to do this question. I'm giving you a question. It's a very simple question. Just try to do this question. Okay. If somebody is there, let us do the last question today. Let Xn be a sequence. Let Xn be a sequence, and let A be greater than 1. Let A be greater than 1. Assume that xk plus 1 minus of xk modulus is less than a ki power of minus k for all k belongs to natural. For all k belongs to natural. Then what do you think? Will Xn be a Cauchy sequence or not? Will Xn be a Cauchy sequence or not? And tomorrow also we are going to focus much on Cauchy sequence and its questions only. So please do attend your lecture tomorrow also. So you'll be able to fix this particular concept. And this is an important concept when it comes to examination. What do you think about this sequence? Will it be a Cauchy sequence or not? Will it be a Cauchy sequence or not? So in order to verify that this is a Cauchy sequence or not, what am I going to do? So see, understand the fact that xk plus 1 minus xk mod is given less than a ki power minus k. And what do I need to estimate? I need to estimate this. So I will estimate xm minus of xn for all m greater than n greater than equals to n not belongs to natural. So here is your m, here is your n. So this would be n plus 1, this would be n plus 2, dash dash dash, this would be m minus 2, and this would be m minus 1, and this would be lastly m. I hope it is clear. Okay, now see, I know all these things because see, whenever you have to make an assertion about Cauchy sequence, what you need to estimate? You need to estimate modulus of xm minus of xn, isn't it? So what I'm going to do is, I'm going to write it in this fashion. Xm minus of xm minus 1, xm minus 1 minus of xm minus 2 plus xm minus 2 minus of xm minus 3 dash 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 dash, and then you will have the last terms following up. That would be xn plus 2 minus of xn plus 1 and plus xn plus 1 minus of xn. Now you would be thinking why I'm doing so. See, because the hint is given between in terms of absolute value of the difference of the consecutive terms, isn't it? The hint that you're getting. The hint you are getting. Now you see, this is how I can write. So if I'm writing modulus of xm minus xn, it will be less than equal to modulus of xm minus of xm minus 1 plus modulus of xm minus 1 minus of xm minus 2 plus modulus of xm minus 2 minus of xm minus 3 dash 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 modulus of, you will have this xn plus 2 minus of xn plus 1 plus modulus of xn plus 1 minus of xn. Now you see, this particular thing is already less than a ki power of minus of n, right? So if you remember, here it was k and here it was k, right? So if you think about this, this would be less than. So overall I can write all these things like in this fashion. See, so I'll write that my xm minus xn mod is less than a ki power of minus of m minus 1 plus a ki power of minus of m minus 2 plus a ki power of minus of m minus 3 dash 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 a raised to power minus of n plus 1 plus a raised to power of minus of n. Or, and see, a was given greater than 1, so 1 upon a would be less than 1, right? If a is given to be greater than 1, then 1 upon a would be less than 1. Let us write this 1 upon a as zeta. Okay, let us write this as zeta. So xm minus xn mod can be written less than zeta raised to power n plus zeta raised to power n plus 1 plus zeta raised to power n plus 2 dash 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 zeta raised to power of m minus 3 plus zeta raised to power of m minus 2 plus zeta raised to power of m minus 1. So if I want to write it collectively, I can write that my xm minus of xn modulus is less than, what it will be equals to, this will be equals to zeta raised to power n 1 minus zeta raised to power m minus 1 minus n plus 1. So m minus n would come here divided by 1 minus of zeta, and this would be less than zeta raised to power n divided by 1 minus zeta. And I know that limit zeta raised to power n would be 0, since zeta lies between 0 and 1. So what does it imply? Zeta raised to power n upon 1 minus zeta minus 0 can be made less than epsilon for all n greater than equals to some natural number n naught. Now what does it imply? It implies that xm minus xn mod can be made less than epsilon for all n greater than equal to n naught belongs to natural and n is greater than some m. So obviously this qualifies the definition for Cauchy sequence, so therefore xn is convergent. I hope today's lecture you would have got a good idea of convergent sequences and Cauchy sequences and how to implicate them in question. I hope to meet you tomorrow in a similar lecture where I'm going to discuss in detail a few more examples on contractive sequence and Cauchy sequences. Please keep in mind that such rigorous question may not be asked in your examination. However, when you will study the series part, I'm going to give you a reasoning that by which only by seeing you can give an answer to such type of question. So please keep in touch. Till then, take care. Good night.